What is that?
Explain.
Somebody explain.
Someone explain.
Somebody explain.
Someone explain.
Please explain.
Someone
Is it
anyway.
glue?
Kind of.
Is it glue?
We combine.
Oh, hello. Introduce yourself.
Hi, my name's Erin. We combine sodium silicate with.
It is sodium.
Yeah, that is sodium silicate.
Yeah, we
It's
combine
plastic.
silica and
Silica and
sodium hydroxide.
sodium hydroxide, along with some water. We used a 2-to-1 ratio for the sodium hydroxide to the silica, and it was more of a trial run. We tried
That
and
was a
tried
lot.
again, but now we are making, and we are combining it with trash to make trashcrete. It's a substitute for concrete.
So who are you? I mean, you said your name. You haven't all said your names. Who are you? Like, what is your group?
Oh.
All right.
Sorry.
Identify yourselves.
We are Engineers Without Borders. We focus on international projects as well as local projects.
Engineers Without Borders. And so we need other names. We got yours.
I'm Chase.
The president.
Yes, the president. Sorry, I'm very focused on porn right now.
Okay. Chase, the president of Engineers Without Borders at the University of South Florida, Tampa. And?
Isabella.
And?
Jessica.
She's the local project lead.
Local project lead. And I'm Dr. T.H. Culhane of the Patel College of Global Sustainability. And you are plastic shred from bottle caps and toothbrushes. There's a toothbrush right there, made of HDPE. And there's the sodium silicate. What you said, where did you get the silica from?
We collected the silica, or you can buy silica.
So where did we get this one from?
Collected it from students. From
Silica
your
gel.
students.
Yeah, it's the silica gel packets.
Silica gel packets that come in like
jerky.
beef jerky,
Medicine bottles.
other things to help preserve the and keep the longevity of the product.
Because they're desiccants.
Yes.
We got ours, most of ours from our family came from seaweed packets.
Oh,
The
yes.
seaweed
Yeah,
flakes
That's
one.
another one that they
Yeah.
come
That's
in.
a really
That's
great
really
one.
Good, yeah.
The
That's
seaweed
it.
one. So
Forgot about that.
they're pretty big, so you get a lot of silica. So we took a bunch of packets. And how many grams of, or not grams because we didn't use weight measure, we used volume, but how many milliliters of silica gel crystals did we use?
We used 100,
Yeah, 100.
and then we did 200 to 250 of the sodium hydroxide, as well as just adding water.
Those crystals. So we used crystals of sodium hydroxide. We didn't use
Yes.
Drano.
Yeah.
And then we had about the equivalent amount of water.
Yes, it was kind of like around
Yeah.
the same ratio.
And how did we do that procedure so that if people want to try this at home, they don't hurt themselves?
Please wear the proper protection equipment.
Yeah, eye goggles and gloves and aprons.
You need a heat source
Uh-huh.
as well as to stir.
Oh, boy, do we need stirring.
Stir.
So what did you start with?
So we started with first measuring out and making sure we had the ratio right.
Did we start with the water?
Yeah, we
You always start with the water.
and then we combine the water with the sodium hydroxide.
Or we rather we combine the sodium hydroxide with the
To the
water
water,
because you do
yes.
not want to add water to sodium hydroxide. It'll sputter and put all sorts of caustics into your eyes and your skin. So yeah, so it was 100 ml of water, no, 250 mLs of water. Then we added 100 ml of sodium hydroxide crystals into that.
Yeah, it
And
was 200.
200.
Yes, and then 100
200?
silica, right? Or
Yes,
am I getting
100 of the silica, 200
Good of
of
the-
Right, because we met it starting
Yes.
with the amount of silica that we
Yes.
collected, and we only had about 100 ml,
Yes.
right? Okay, so we put in 200 mLs of sodium hydroxide crystals into 250 ml of water, stirred it up. Did we heat it at that point, or was it?
It started heating and kind of
By
gaining
itself?
temperature by itself. Yes.
How hot did it get? 70, I think.
70. I think we kind
High
of stopped it around
60s.
70. Is when
70
we added
Celsius,
the
right? So we
silica.
heat it, we let it heat up naturally to 70 Celsius, and that's where it sort of stopped. It started going down to 69, and then we started adding the
And then
silica,
we put it on heat.
and then we put it on heat,
Yes.
on a
Gas.
propane,
Yeah, propane.
little propane burner, right? And then,
Just stirred for
stirred.
45 minutes to an hour.
it was like an hour at the end, right? At 40, wasn't it like 47, it started to froth?
Yes, and then that's when we also had a fan.
Ah, the
keep it
fan.
From frothing.
Yeah, talk about the fan.
What is there to say? It was a lot of learning as we go, turning it on, turning it off, kind of just seeing what it
Just trying to
did.
keep it from frothing.
We wanted to avoid the frothing.
Do you suppose we could have achieved that without the fan just by lifting it off the flame?
Maybe.
Perhaps.
That might have been
Probably
easier.
should.
I
Maybe.
don't know. I don't know why
We were just.
But the fan was good because it was blowing any possible fumes away
Yes,
from us,
no,
and the
it was good.
mosquitoes. I'm saying the mosquitoes were
Those
there.
mosquitoes, yeah.
They were pesky. So now we've made. Can you show what it looks like inside the liquid itself?
Oh, yeah. Let me open that.
Yeah. And we're hoping that it's going to bind with this plastic, right? And is that so? Can you pour it? Like, is it kind of? Do another one. Can you pour one as a control without any plastic?
Yeah, see what
Let's
it
see
looks
what that
like. That's
looks
a really
like.
good idea.
Right. So that is sodium silicate. Do we even have enough left to
Yeah.
do another? So let's leave that in the bottle.
Yeah, I want to leave some in the bottle to see what happens.
Yeah, because it's apparently it's going to absorb carbon dioxide from the atmosphere in order to harden. And if it's in the bottle sealed, then there isn't a lot of carbon dioxide unless you were breathing into it.
I don't think I would.
You'd know because the mosquitoes would be chasing it in.
Yeah.
So okay, so we have a control. We have plastic shred bound up in these, and we have a toothbrush. And we got the plastic shred. This is all HDPE. Over here we have a mix of 1 through 7 that is not as finely shred, and we will see how that binds too. Doesn't have as much surface area because it's bigger shreds. But ultimately that would be the goal, is to be able to do that, because this is a more expensive product, let's say, because this is just every plastic without any sorting. So there's no minimal labor, even though we're using a big machine to do it. This, you have to take off the bottle caps and make sure that you're not contaminating them with anything else. And so it is less utility for the animal sculptures we're doing. But this is going to be really cool. And show people that is silicone. Interesting how silica makes so many things. So if you bend that
Oh
end,
yes, this you can push up.
Yeah.
So
So these are not cookies. Don't eat them. But they are going to be non-toxic because it's just water glass.
yeah.
What are the other advantages? Not flammable. We think we should be able to take a blowtorch to them. Yeah, this is like a refractory cement substitute that you could use and make vessels, like retorts that you could put ceramics in, or put, glass itself. I don't know, because it is glass. But it's supposed to be a substitute for concrete, for cement, for making concrete. But it's very expensive because of the cost of the materials. And we want to ultimately not use silica packets. We want to use glass covered. But they said, ChatGPT told us, what temperature do we need for that?
1,100
Celsius.
Celsius, which is
Holy
hot.
moly. And how hot did we get today?
we got to 160
Almost
ish,
170 at that
almost
one time.
170, yeah.
165.
170 Celsius.
And that's when it started to froth.
Yes.
Dangerous.
And then we kept adding water whenever it would get hard, because at one point it became really cakey.
Yeah.
But then we put it back on the fire. And then so this is, all right, so those of you, do you want to turn this camera around for a second? So for those of you who are just joining us, this is the experiment with Engineers Without Borders at USF Tampa, working with the Patel College of Global Sustainability. This wonderful group of young people who see a bright future are using their academic and their heartfelt acumen to find solutions to the world's greatest problems. And one of them is the amount of CO2 emitted by construction materials, particularly the production of cement, the use of cement. Whereas water glass, or sodium silicate, which is produced simply by sand and sodium hydroxide, which is lye, which is Drano, which was used to make soap and a whole bunch of other things. I mean, it's just a salt, sodium with a hydroxide, which is just water, hydrogen and oxygen. So that is a very non-toxic, very safe, as long as you don't get burned, chemical reaction to make this binder, this glue, which we have in this bottle of formerly crystalline drain cleaner. But now it's got the water glass in it. And we don't know how long it's going to remain without hardening in here, but they say that when we seal it, it won't harden because it doesn't have carbon dioxide. It's a carbon sequestering binder. So imagine if we make bricks out of it, if we make blocks rather than using cement, the buildings would begin to pull carbon dioxide out of the atmosphere and help us draw down these greenhouse gases. So there's a lot of good narratives that we can draw from this. But right now we're making bunny rabbits and carrots. And that's kind of cool. So thank you. If you were watching, please leave comments. What do they always say? Don't forget to like and subscribe. And we'll see you in the movies. Thanks.
Yay.
Oh, you didn't turn it off?
I don't know how.
Oh.
I've never done YouTube Live.
Notification. I don't know.